So the objective of the lesson is to understand the concepts linked with the unit circle. Now, the three ratios that we are going to talk more in detail in this lesson are the sine ratio, cosine ratio, and tan ratio of any given angle theta. Now, when you talk about unit circle, it is very interesting to actually understand the property of periodicity, because if you look around a unit circle is of the radius 1. Now, when you look at the different parameters, now if you move along the circle, which is in anti-clockwise sense, your angle is taken as positive. When you go clockwise way, its angle is taken negative. Now, why I call it the periodicity is probably once I'm explaining you the basic concepts that will become clearer. Uh, Now, let us say if I have a point x comma y on this unit circle. Now, what happened is that if I project the lengths, this length is 1 because that's the radius. This is x and this is y. So in general, what happened is if I apply normal, if this angle is, let's say, theta, if I apply cos theta is adjacent over hypotenuse. So cos theta is x here. And now the value of sine theta, if I take it, is y over 1, which is sine theta is y. Now, if I specifically take the coordinates, the x comma y, so any general coordinate on the unit circle can be written as cos theta comma sine theta. Now, for example, if there is an angle which is, let's say, 60 degrees, and this is along a unit circle here. So this is 60 degrees. So the coordinate of this point will be cos 60 comma sine 60. So this is the basic idea of the unit circle. Similarly, if it is here, let's say this angle is 120. So this is going to be cos 120 comma sine 120. If I'm here, it is, let's say, somewhere 240 degrees. This is will be cos 240 comma sine 240. So generally, any point along the unit circle, its coordinates are given by cos theta comma sine theta. Now, before I go ahead, I just want you to remember this triangle, the 30, 60, 90 triangle. So 30 is 60 here and 90. So 45, 45, 90 triangle. 45, 45, 90. Now, what is really specific about this triangle is actually, so opposite to 30 side, if I take 1 unit in length, this side is square root 3 units in length, and this is 2 units. If you apply simple Pythagoras, you can get one of the missing side that you can verify with. This is 1, 1 and square root of 2. Now this becomes a very specific tool for us to not mug up many things like a table or something for trig ratios. So for example, if I want to estimate sine 30, you can just use it opposite over hypotenuse, so which is half. Cos 45, which is, I can take adjacent over hypotenuse, which is 1 over root 2. Then tan 60 is basically square root of 3. So opposite over adjacent, and so on. So you get the basic ratios using these triangles. Now coming back to the unit circle. Now let us say this is a unit circle um, drawn with the ratio with the principal x-axis, which is positive direction of x-axis. And now there is a point which is here. If I pick up the coordinate, which is, let's say, 60 degrees here. Now, as we know that cos 60 comma sine 60 is the general coordinate. Now, what is that cos 60 length? Cos 60 length is actually this length. And then this length is sine 60. So actually the length along y that measures the sine ratio, length along x measures the cosine ratio. Now, what is really interesting is that if you look at that, the x distance is actually positive here. So all the ratios, like all means x and y both are positive. So sine, cos, and tan, all ratios are positive. And if you're in second quadrant here, because x length is negative, so cos is negative, and sine is positive. So your sine is positive because your y value is positive. If you're in quadrant number 3, your sine is negative. This is negative, and cos is negative, and your sine is negative too. So ASTC is a rule, like any way you can remember, all silver teacups, or like add sugar to coffee. So that way you can remember. So here in the first quadrant, all ratios are positive. In second quadrant, sine is positive. In third quadrant, tan is positive. Only it means that other ratios are negative. And in fourth quadrant, only cos is positive. So let's make use of this and try to do some problems on this first, understanding of the unit circle. So assume that this is the unit circle that I'm drawing. Here is my x-axis, and this is the y-axis. Now, what I'm going to do is I'm taking, let's say, the position of an angle here. So the angle for me is actually at 120 degrees. Now, what I wanted to find out is what's the coordinate of this point. So what's the x and y coordinate of this point? So x and y. So when you find out the x and y coordinate of this point, actually it's cos 120 as per rule and sine 120. So that's the coordinate. But how do we get this without calculator, without using calculator in this context? So if you look at actually, now if I pick up this angle is actually 60 degrees. And if I pick up, let's say, another angle, which is here, which is, let's say, 60 degrees. Now, what you notice is that this is the distance that I was calculating for sine 120, which is actually same as sine 60 distance. And this distance, which I was calculating for cos 120, and this is same as cos 60 distance. So actually, I'm not using this 120 directly anywhere. I'm using this base angle. So what happened is that actually, whenever you're finding the ratio of any obtuse or reflex angle or anything even more than like 360, you got to find out the base angle with x-axis. Remember, base angle is taken only with x-axis, only with x-axis. So what happened is that if I take for me, when I'm finding sine 120, my base angle is 60. You blindly say, okay, it is going to be same as sine 60. Cos 120 is going to be same as cos 60 because that's my base angle. But here, if you look at in the quadrant number 2 ASTC rule, you notice that your cos is negative because cos 120 is in second quadrant and hence it is negative cos 60. So sine 60 is a root 3 over 2. If you use the triangle that I drew, 30, 60, 90 triangle, I'll just redraw it here. So root 3, 2, and 1. So you can see sine 60 is root 3 over 2. And negative cos 60 is negative half. So this is how you first do the basic problem on the unit circle. All right, so next up is, let's say I wanted to find out the value of any angle that is beyond 180 or let's say beyond 360 as well. So let's say I wanted to find a cos of 300 degrees or sine of 300 degrees. Okay, so when you find out this angle, or I want to find out cos of, let's say, minus 120 degrees. So first, let's take one by one. My first thing is that to locate the angle. Where is the angle? So if I pick up my first angle, it is here. So 300 is somewhere here. And now base angle, this is the 300 is actually when you write, this is the angle that you're looking forward to. So now the coordinate of this point is the cos theta, cos theta comma sine theta. So cos 300 comma sine 300. So actually cos 300 that I'm taking is actually this distance, which is here. This is cos 300 and this is sine 300. So you can clearly see that the base angle is 60 degrees here. So cos 300 is same as cos 60 and it is in fourth quadrant. So that's why it is positive. So this is why it is half, and sine 300 is same as sine 60. And this is negative root 3 over 2. Negative because it's in fourth quadrant. in fourth quadrant, you can see the sign is negative here. Now, when you want to find out sine 300 and cos 300, you follow that procedure. Now, if I want to find out cos of minus 120, now to get the cos of minus 120, you got to locate the angle, which quadrant is your angle in. So I'm just gonna locate the angle now. So the angle actually, if it is negative, you go clockwise. Okay, so the clockwise angle is 120 somewhere here. So this is your 120 degrees. And this angle is actually cos of 120, comma, sine of 120, negative 120. So to find out this, I am going to use once again this base angle 60 degrees. So this is same as cos 60. This is same as sine 60. So blindly you can write down, okay, cos negative 120 same as cos 60, sine 60. But because you know that these ratios are going to be negative, because this is also negative and y is also negative. So that's why it's negative. So negative half, comma, negative √3/2. So this is how you basically do the basic concept of unit circle using, using the unit circle, you can predict for the angles that are higher than 300, higher than 360 also. So let's take a couple of examples on that. Now, some more example on how do we use unit circle to find out the angles. So let's say if I wanted to find out, let's say sine of 480 degrees, or cos of, let's say, let's do some questions in radians as well. Let's say 5 pi by 6, and tan of, like, let's say tan of 7 pi by 6. So how do we find out these angles? The ratios of these angles. So first thing is that you got to locate the angle, which quadrant is your angle in. So I'm just gonna start with the first one, which is 480. So the 480 is 360 here, clockwise, anti-clockwise, and then further 120 degree. So actually my angle is in the quadrant number 2. So this is where it is. 360 plus 120 is 480. So this is 480 degrees angle. Now actually the base angle is still 60 degrees, because this is 120 in short and this is 60. The sine of 480 blindly you can say is same as sine 60. Now just check on the sign. So ASTC, here sine is positive, so no worries. This is positive sine 60, which is √3/2. Now if I got cos 5 pi by 6 here, it's if it is 5 pi by 6. Now 5 pi by 6, if I convert into degrees in your mind, you can do 5 times 30 degrees. So 5 times 30. Okay, so to find out the value of cos 5 pi by 6, you can convert it into the degree form by, so let's say degrees to radians if you want to convert. So degree to radian is multiply by pi by 180. And from radian to degree, multiply by 180 by pi. So 5 pi by 6 is actually 150 degrees. So 150 is somewhere here. So it's the cos of 150. That's when you find out. So cos of 5 pi by 6 actually will be same as cos 30. So cos of 30 degrees. So now cos of 30 is going to be √3/2. But now whether it's positive or negative, so that's negative because it's in quadrant number 2. So that's why this length is actually negative. So this is same as negative √3/2. Now tan 7 pi by 6. Okay, so when you want to find out the value of tan 7 pi by 6, you first are going to draw the position. So that 7 pi by 6 is actually 210. Actually, if you convert into degrees for better understanding. So this is 210. So actually the base angle now here is 30 degrees. So tan of 7 pi by 6 is going to be same as tan of 30 degrees, but is it positive or negative? It's an ASTC, so here tan is positive. So that's going to be tan of square root of 1/3. Tan 30 is 1/3. So this is how you do the basic ratios of the angles that are not in the first quadrant. All right, so here what we have is we have got the first angle, which is 11 pi by 6. If you convert into degrees, is somewhere here, which is 330 degrees. So 330 degree is the angle. So the principal angle or the base angle is 30 degrees. So this is going to be same as sine 30, but since it is in quadrant number 4, it will be negative. So answer is negative half. Now, looking at the next up is negative 3 pi by 4. So negative 3 pi by 4 is negative 135, actually. So the base angle is 45 degrees. So that is 1 over root 2, but it'll be negative. So this is same as cos 45, but it'll be negative. Now tan of minus 300 is actually here somewhere. So tan of 300 is negative 300 is this angle. So the base angle here is 60 degrees. So it is going to be same as tan 60, which is root 3. Now, sine of minus 270 when you talk is actually, this is the angle, which is negative 270. So when you find out sine of negative 270, it is, this coordinate 0, 1. And you know this cos theta, sine theta, the coordinates. So you can just take this as the value, which is 1. Similarly, negative 180 is actually this angle where the coordinate is 1, 0, negative 1, 0. So this it's the coordinate is cos theta, sine theta. So cos of this angle is actually negative 1. So this is the answer. Now tan of negative 315 is in the first quadrant here. So that answer is tan of basically same as 45, which is 1. So this is how you do the basic concepts, basic problems on unit circle.